Great. So now that we have our simulation working, let's set up a sort of production-minded way of caching and rendering. So, of course, we have our cache frames here, as evidenced by the blue bar on the bottom. But you're never actually going to just render the simulation itself. You can turn it on here, and you could actually technically put that over here in the Mantra Force Objects area. And also, as a side note, you'll recall that this used to be called Geo1, and when we set this up earlier, we put Geo1 there. But the nice thing about Houdini is it knows what you meant. There's basically like a reference to it. It will update on its own, which is pretty sweet. Anyway, so it says source now, which is actually not what we want to render anymore. We want to render the output. The source, of course, is just this thing. We want to render this thing. Oh, we lost the cache. All right, so let's make a output. It's just going to be another geometry node. No different than the other ones we've made. The shape, let's say, the contents of it, though, we're going to read it in from the simulation. So dop import fields. So again, the dot was the dynamics operator land. We're importing it, of course, from there back into SOPs land, because we're in geometry. And fields refer to the volumes that are within the simulation. So we could import, if you're doing like an explosion later on, we could import not only the density, but we could also import the temperature maybe, the velocity also for motion blur. Right now we're just going to grab the density. So for dot network, let's point to it, dot net 1, great. So we still don't see anything. That's because we actually haven't asked for anything in particular yet. And if you recall, inside of the DOP object, we have these different things. We have these different elements in that container: pressure, density, volume, or velocity. These are the things. This is the data that we can import. So in particular, we're gonna want density. So we know the name of the object is smoke object 1, again here, and we know the subdata is density. So we want smoke object 1's density. So we go over here and we say field is density. Oops, cannot spell. If we know that we're going to import everything from the same object, you can put it here. Otherwise, you can do it per field down here. So there it is. So now we have it again. The volume's called density. That's how big it is. And then there you have it. You'll see it's hesitating as I scrub because we actually lost the cache. And that's going to happen every time we make a change to our dynamics network, and honestly, sometimes just other things that I don't even know, the cache will disappear. So let us actually write the cache to the disk. And then we can just read that from the disk. And also, this particular way of storing the cache will store it in Houdini's native BGO format, as opposed to the simulation sim format. We're going to actually use this cache also to render from, as you'll see here. So I put a null down that just says, hey, this is a pointer that we can point to now. So over in Outland, the Outlanders, if you will, we have the Mantra ROP is going to output images. Now we can also output geometry itself. So I'm going to make a geometry ROP. Now this is different than the geometry node from here, this geometry operator. This geometry operator has well, first of all, it's in the scene context, but it has inputs and outputs for parenting. In the inside of it is basically what kind of geometry is in it. This isn't anything like that. This is only an operator that will write out a specific location to the disk. And it's pretty straightforward. This is what we're going to want to write out. So I'm going to click and drag this over to SOP path. Again, these are SOPs. This is the path to it. And you can really start to see how it, it's kind of like a file server, or again, like a website. It's this/this/this, because we're in, we start in object land /output/cache sim. So that's this address. And then where are we going to put it? Let us put it in, let's use that job variable we defined a long time ago. So job, cache, and then we'll call it just cool sim cache. We'll say it's this version 1, maybe we'll do another one later. $F for the frame. That's the variable that will change per frame. And bgeo.sc is the Houdini file format for storing geometry. Right now it's set by default to set render current frame. Let's change it to frame range. I don't feel like doing the whole thing, so this does say start to end. We could just say let's just do like 40 frames, I don't know. That's fine. Everything else is pretty much fine. Great. So now, oh, and I'll also have it redo the simulation every time. I don't want it to accidentally pick up a broken cache in case we messed up our sim somehow. So now when we click this, it's going to read this path, which in turn is reading from the simulation over here. And of course, the simulation is in turn reading from its initial data here, which we can follow through, all the way back to the pig head. So again, Houdini being super procedural, if this pig head got updated, let's say, again, in a production context, modeling updates the pig head, or if this is an animated whatever, animation changes, or you just decide, hey, maybe I'll start this with more resolution, or maybe I'll pump it up with more density, or any number of things could change along the way. There's nothing you need to change. You don't need to reset up anything. All you need to do is click render on this. And you can see here, pop, pop, pop. You see it's solving, gas, advect, all that jazz. So it just wrote all of these BGO files to the disk. Actually, that version 1.1 is kind of confusing, isn't it? Well, we'll come up with a better name for it later. But in any case, it's version 1 frame whatever. In fact, you can put a 4 here, and that would have been better. That'll give us some zeros to really make it look like a frame number. There you go. So there you have it. Great. So we have those written to disk. So now what we can do is we'll make a file sop. And you might remember this from before when we were plopping on this geom node. These come in by default. This is going to read that file back from disk. So let's just reference this in case we update this path later. So right click and hold and go to copy parameter. Right click and hold and go to paste references. And now it's going to check the string, that's what C, or channel string really, of this path. And that's what this is. If you hold your mouse over it, you'll see it says parameter sop output. That's what this is. This is the path to the node and then to the parameter on it. So basically by middle clicking on this, you'll see it's resolving to what this resolves to, which is the same thing. So it's a fun little way that if I update this, this will update too. So now this is going to read those files. And when this is set to read, it's going to actually ignore the incoming connection. In fact, I can just break it and you'll see it still reads it. And I only did like 40 frames, so there's nothing, and you get this error after that. I'm going to keep that connection on. If you did automatic, it will check the incoming path and see if the file exists already. And if it doesn't, then it will evaluate the node and write it as normal. In this case, we know we only want this to work from cache data. We don't want this to accidentally run a simulation if the file doesn't exist. Cool. So now we have that, and we'll put another little null after him and say, render me. Cool. We'll just keep that there. So now this output is what we want to render. So we'll go back to the Mantra node and we'll say force objects output, not the source one. Let's keep it on here. Cool. And there you go. So again, even if this is off, this force will literally force render it. So you don't have to remember to keep this on or off or anything like that. So let's just go to a frame like this and say Mantra 1. So this is going to trigger this Mantra node to run. It's going to force object that one. And I wish my computer was faster. There it goes, slowly but surely. So this is because we're rendering in the HQ settings on right now. So this is a perfect example of, it's kind of like, it's taking forever. So I'm going to escape this, kill it. Let's always have it render an LQ right now, because we want faster feedback on our work. So here we go. Look how much faster that is now. And we could really even decimate this further, but this is going pretty good. You can see how much grainier it is now. So there is one of the frames, apparently frame 27, of our simulation. So the very last thing that I want to do is, well, no, I lied. There's two things I want to do. One is, let's set up a material real quick. You could go to the little fun gallery, the material, where are you? Material palette. Let's go grab the billowy smoke and, oh, here it is actually. Let's go back to the parameter view. So billowy smoke, these are basically just materials that are set up for you already that have some common things. So it's actually built out here in the Vex shader builder land, and we'll definitely get into that later down the pipe. But for now, we can just rely on billowy smoke. That works pretty well. So this is going to look for that density field, remember. And if we middle click, we'll see that we have a volume density. That's what it's going to look for. And it's just going to multiply the values times 1 and the shadows times 1, and everything will basically look the same. But now we can tweak these post-sim. We don't have to add more density into the simulation in order to render it more dense. So let's choose like an earlier frame. And I'm also going to say LQ mode. I want to update my Mantra ROP is angry because I canceled the render, not for anything else. So let's have the pixel samples actually be 2. Oops. For our render, and we'll go back to main now. So this is again pointing to LQ mode. So even though it says 3 here, when it renders, it's going to actually use these 2s. So we assigned the material, billowy smoke, to our object here, and now that we've proven that it will force render, I'm just going to turn it back on. Let's render it, see what we get, and now if we decide like, oh hey, this is fine, but hey, I think that maybe this could benefit from a lot more density. So I could just say like, boom, 10 times as much. Cancel this, render, and now the materials interpretation of the underlying simulation data will say that, well, I know the density is only 1 here, but hey, let's just multiply that by 10. And you can see immediately how much denser it is. It's kind of like when we were playing with the volume mix before on the source side, except now we're not resimulating anything. We're just, playing with these numbers. Actually, instead of changing that, I'm going to change the shadow density. This will make the dark areas, of course, when it does the lighting calculations, it'll say, don't actually change the density of it, but treat the shadow rays as denser. And again, that's the kind of advanced stuff we'll get into later. But cool. You can see basically how we can play with it in the material in a quick way. And that's what this production stuff's all about. We're trying to set things up to iterate quickly. And on that final note, the way that nodes connect here in the output area is pretty cool. What this does is this will run these nodes as a dependency. So this is, if I say I want to render the image, it will render the image, but first it's going to wait for this, which is important. So if I'm working on something or other and I say, okay, well, I need to change the sim in some way, like I need to have the gas turbulence start at like, I don't know, now I want it to start at 25. And now I want to go off and do something else. I can have this Mantra node say, by clicking on this purple thing here, if I can get it, there it is. I could say, okay, do this node by node. And what's going to happen is it's going to run the simulation here, cache it to disk, and then the Mantra ROP is going to run. And because of the way we have it set up, it'll all just fall together. It'll run the sim, and then the render will read it back from this. So all we need to do is click node by node and click render, and you'll see it's caching everything out, and then it's rendering it. And that could save you a whole lot of time if you want to go home from work for the day and you don't want to wait for a cache and then feel like, okay, now the cache is done, now I'm going to render it. You just can be confident that this will cache it and then it will render it. I mean, this is also good even, on your in your own work, on your own computer. Same thing, especially in a place where you only have, the capacity to do one thing at a time. Go to sleep, let it cache out, and then wake up in the morning with the cache done and your renders done.